All right, hello people. I'm gonna try this again. I just got interrupted and had to start all over. This is a little golf cart. I call it my little geriatric cart, and see the little handicap sticker on there that somebody put on there for me. We have to use transportation to come in and out on the flight line where I work because of the distance. And let me show you over here is where our hangar is, and you can see how far away that is. And over here is operations, where they load and unload passengers and luggage and things of the such. And so we're going to be doing the EC135 today, which is the aircraft that I primarily work on. And this is it. We have 4 of them. We have 3 that operate basically just out of this base, and we have 1 that does energy line patrols for the electric companies, and it moves to different places across the Gulf Coast to check power lines. All right, we're going to start on the left side, and here it's on, the aircraft is on what we call 6 landing gear, skids, and this is a combination of a float and a raft. And back here is just a float, and I have my tie down equipment kind of scattered around because I was in the process of doing this video, and then a helicopter started up, so I had to stop, and while it was doing that I just started to try to tie it down. And this is the bottle that contains helium to inflate the raft. And up here is the cowling portion for where the transmission's at, that turns the rotor head. And then over here is where the engines are. There's one on each side. It's a twin engine helicopter. Has Pratt & Whitney PW206 B2s in them. Very nice engines, easy to maintain. And this is a maintenance friendly aircraft as far as I'm concerned, of all the ones, different models I've worked on. And this is the baggage compartment, where they can put the cargo or whatever they need to put in here. And you can see the back of the rear seats, but just behind that there's 2 seats that can be put in here, and I'll talk about here in a little bit. We're going to walk to the other side so I can get a clear picture of the tail rotor on this aircraft, because it's a unique one that's called a fenestron, and it has 10 blades on it, and it's quiet, but it's not very efficient as a normal or typical tail rotor bladed aircraft. And because of that, this thing has a huge tail for stability. Once it starts moving and going forward, the air flowing across it, helps stabilize the aircraft. And it has a habit when they pull up that any wind or whatever will make the aircraft kind of move side to side. And then you can compare it to this aircraft, and you can see how small the tail is on that, and that's a 119 Koala. Okay, and it's on this side we have the same setup, float raft combo, and another float. And this is the bottle just for the floats, and you can notice it's much larger, has helium also in it, and like I said, it has larger because of the volume of the bags. These things are huge when they come out. And then here's a T-handle that pulls the raft. I'll explain that later. And I have a power cord attached to the aircraft so I don't kill the battery in the aircraft while I'm doing this video. Okay, here's the rear seat. Has 3 passenger capability. Like I said, everybody has to wear a life vest when it goes over water, and most of our flying is over water. And this seat can be turned 180 and mounted over here for the other two seats, let's say, which go in the baggage compartment, you know, in this area. And this is their window that they can look out of. Okay, so now we're going to go inside. And so I think explain the instrumentation, the radios, and the flight displays. Okay, starting on the left, this is the transponder. It puts out a code that transmits to the tower and other aircraft that's capable of receiving that information. And if you notice, there's the number that's tuned into it, and the ID is the N number of the aircraft. So those two pieces of information, plus altitude and airspeed, and sometimes, you know, other aircraft can see your direction, and then the towers will always see your direction. And then over here is the warning panel. This has all red lights. This is the bad section, and whenever something bad happens, you know, the lights will come up here in red, and there's rotor RPM and transmission oil pressure, and the reason they're illuminated is because the aircraft's not running. And I'm going to hit the switch to show you the other ones. Okay, and then on the outside of left and right are guarded switches for in case there's an engine fire. That's where you can turn the fuel off. Then we come down a little bit, and this is what we call steam gauges. And this aircraft has redundancy, two of everything, and except for this clock, really. This is the chronometer the pilot uses for startup and things like that, because, you know, you have to have a certain time limit starting and other things. This is the airspeed indicator, the artificial horizon, which is electric, and an altimeter, and a rotor RPM. And down here we have the CAD, which stands for Caution Advisory Display. And over here we have the VEMD, the Vehicle Electrical Management Display. It's two screens, but it's one unit. The upper one monitors the transmission and the engines, and then the lower one measures or monitors the oil pressure, oil temperatures of the engine and the transmission, and also the aircraft's voltage. Then we move over to that's an OBS selector. That's a part of the navigation redundancy side. And over here we have the GPS navigation and communications radios. The upper one is the main screen that they use. The lower one is the redundant backup one in case the upper one fails. And that's, you know, where the pilot does all his, you can switch over his different channels he wants to use and things like that. And he can see his weather on there, his weather radar, and a whole lot of things that don't have time to explain. And then we move over here, we have the pilot's primary displays for his aircraft attitude and his heading. The top one is called the PFD, which is the primary flight display, and the lower one is the navigational display. Then we're going to move over here to the bottom on the what's called the slanted console, and then a little further back, basically what they call the center console. Okay, so here we have what's called the RCU, the reconfiguration unit, and this allows the pilot to control the information components that feed information to these two displays. And then you can see that the knobs are labeled 1, and then on the middle it says N for normal, and then 2. So there's 2 of everything for those components. and it's in the normal because the system in normal runs on the number 2 side, and then it uses the number 1 side as a comparison. So if there's any errors going on the number 2 side, if it miscompares with the number 1 side, then you'll get arrows in these 2 displays that warn you about it. And then you can come over here and select 1 or 2 to see which one is causing the problem. And the FCDM is for their displays, and the AHRs are 2 boxes in the belly that have gyros and electronics in it that feed information to these 2 displays. And the FCDM is for, there's 2 modules in the back that drive these displays. Like I said, there's 2 of them, because if one fails, the other one, is used, as a backup. This aircraft is able to have a second set of displays over here, but we don't have them. And then it would use both cards in that case, or modules. And then you have what's the ADC, which is the air data computers, and that feeds the information for the altitude, the airspeed, and things like that. And they're mounted in the side channels in the floor. Okay, then we're going to come down here. This is with the TFM 550. This is basically high frequency FM radio that's used to communicate with offshore vessels or platforms and things like that. Then we have the ICP, and that's stands for the instrument control panel. And when the aircraft is on the autopilot, this is where they can select what they want displayed on their up here again, to whether they want ground speed, vertical speed, indicated airspeed, altimeter, heading, nav, things like that. And then of course there's 2 of them. And then you have the ICS control panels, and this controls the pilot's ability to change what radios he wants to hear. And then of course there's 2 of them. And then up here is the autopilot control panel. And down here is the collective, and then over here is the cyclic. And you can see how this is a 12-year-old aircraft, and the controls are pretty much new. Hardly no wear on them, because the aircraft is always primarily flown by the autopilot, and you can see how worn the knobs are, because pretty much that's how, between these 3 panels here, that's how they fly the aircraft. Once it gets up to 6 knots, it becomes automatically engaged. They can turn it off, but like I said, when it's always in auto. Okay, so we'll move down a little bit more, and this is the DMP300, which has a cord in it for briefing information for the passengers. While the pilot's doing his thing, he plays that, and the passengers can hear the briefing information that you would hear like on an airliner, is what the stewardesses, the flight attendants would put out. This is the sat phone, to where they can call if they cannot reach the whoever they're wanting to talk to on the radios, because the aircraft has a sat phone on it. And these are controls for the 2 units in the tailbone that's called magnetometers. And earlier I said the AHRs down on the floor has gyros in them, and in the tail there's 2 more gyros, but they call them magnetometers. And that's the redundancy there for that, and they are really susceptible to being around a lot of steel. So this allows the pilot to turn them off and on. If they're approaching like a platform that has a lot of steel, they can turn them off, so it doesn't mess up comparison between the two. Going back here is a control head for the FOQA system, which stands for Flight Operations Quality Assurance, and it records everything that goes on in the cockpit, the ambient voice, any voice, things they hear, surroundings and things like that, things that are being communicated on the radios, the instrument, everything that you see up here that's displayed gets recorded on that. Excuse me. And in the back there's a recorder, and we have to pull the card out of it at the end of the day and upload it to a server where people review that data. And back here where my hands at are just basically two push-pull controls. One's for fresh air and the other one's for the heater and defogging. And then over here is the control I'm going to talk to you about for the raft. The one for the floats is here on the cyclic. And then down here where my finger's at, there's a little knob, and that increases the friction on the collective, so where the pilot can pull up on it, set it where he wants it, and then tighten this down, and it stays there, and it frees up his left hand. And then on here, the head of it is a lot of his trim controls for the engines, lights and stuff like that. These are the two throttles for the number 1 engine here, the number 2 engine back here, and this is the emergency side of it. The aircraft is what they call full FADEC. It's all controlled electronically, which stands for Full Authority Digital Engine Control. And if there's a failure or whatever reason and they have to go manual, they can adjust the engines with these throttles, and they're textured differently so the pilot doesn't have to look down to see which one he's grabbing. He can feel that texture difference between the two, and they're trained on to make sure they understand that. And these little things, red locks, are for them to come out of it so they can use it, so they can't inadvertently move the throttles. Alright, this is the cyclic control, and this moves the aircraft left and right and pitches the nose up or down as the pilot needs it, and has a bunch of switches on it where for him to control certain things on his navigation and how the attitude of the aircraft is going. And there's a switch even on here for his radio to where you can see the 2 different channels he's tuned into right here, and instead of him reaching up here to manually move those to select them, he's got a little button here where they'll flip-flop. Okay, then down here we have the tail rotor pedals, and that just makes the aircraft what we call yaw on the vertical axis, basically pivoting left and right, but not turning in a bank. It's just a flat horizontal turn. He has to move the cyclic left and right to be able to make a banking turn, and sort of like a fixed wing. Like I say, if you make a turn, you pull back and then you go a little left, and then that raises the wing up on the fixed wing, and then on a rotorcraft it basically just tips the aircraft to the left or the right. And pretty much that's about it, other than little miscellaneous stuff. We have the compass up here. This is the rotor brake handle for when they're stopping in case of high winds or whatever is necessary. They can stop the rotor quicker instead of just letting it wind down on its own. And this is an emergency door jettison handle. If they get in a crash, whatever, and the door won't open, they could push this and then it'll basically just fall off, which has happened in the past. Not to crash, but the a passenger would accidentally push on it, rest his hand on it and push on it, and the door falls off while it's on the ground. Never had it happen in flight. And then over here we have where the tail rotor pedals would go for the other pilot if there was one in here. And like I said, we normally don't have dual pilots, and they're removed, and this cover is put on top of where the pedals are attached. And that pretty much concludes this little tour, and I hope you enjoy the content, and I would appreciate a thumbs up, and hopefully maybe a subscribe too also. And I'm gonna probably be doing some more videos this when I get a chance. Thank you.